Okay. Hello, everybody. I think I'm unmuted. Yep. So hello, everyone. Thank you for joining us today. Today we have our April session of our Linac Simulators in Action webinar. So I'm going to give a few minutes for everybody to trickle in. We had over 200 registrants this webinar. So, thank you so much for supporting our webinar series. And I'm glad we can cover some topics that seem to be interesting and hope we can continue to do topics that are interesting to you. So, please feel free to reach out anytime and after the webinar for more topics that you'd like to see covered. But today our topic is, using virtual Linacs to calculate MUs. And specifically what I want to look at is how we can use our virtual Linacs to make it very easy and simple to investigate the changes in our beam parameters and then predict or understand how these changes could affect our MU calculation, and not just how they could affect, but the sensitivity that they're going to affect our MU calculations. So throughout the webinar, we'll be using our Linacs, virtual Linacs, to explore these concepts interactively. And just as a quick disclaimer before we get into everything, this is an education session and an education tool, and should not be used for real clinical results. Okay, that's great. So I'll start presenting my little presentation for you guys, and I'll just go through a couple slides, let some more people trickle in before we actually get on the simulators and start doing our demo. So here's our Linac simulators in action, our April session on MU calculations. And so, before we begin, I just wanted to show you guys that, we do have a free access to our platform. And so let me just, this are all the slides I'm going to show you later, but we do have free accounts. And so you can actually sign up at Linacs and log in, and you get 5 free simulation runs a day. And so you can actually log in and sign up, and you can follow along with the webinar today if you'd like to. So just before we get started, if you have any questions as we go along, please feel free to interrupt me, or I have Karen Ann with me as well. And so you can post them in the chat, and she'll either interrupt me or find a good time to make sure we answer that. But I'm happy to pause my presentation any time to discuss things as we move along, if that's of any interest. And just as people keep trickling in here, I did ask you to put any questions or any topics that you'd like to see in future webinars on the registration form. And so I just wanted to cover those quickly, just in case we can dive into them a bit during the presentation today. So some of the questions that were asked that we're either covering today or are currently available are, TG51 protocol for dose calibration, TMR, scatter factors, and inverse square factors. And so we're going to cover some scatter factors in our dose calibration today. But I am also hosting TG51 workshops that go through a full protocol using our virtual Linacs. And so I'll have some emails up at the end of the presentation if you'd like to sign up for those workshops. We were asked about SSD versus SAD calibration, and we're definitely going to cover that today. And we're going to look at treatment from both setups and calculate the MU for that. We were asked about QA performance checks of a Linac, again, TG51 workshop. So I'll show where you can sign up for that at the end of the presentation. We were asked about RF waves. So with that free account, we actually have two. We have a Linac primer and we have a Linac history textbook that you can access. And I'll just show you really quick here that, in our course space with a free account, we have this Linacs primer and this Linacs history textbook, and there's tons of great theory content in here around medical Linacs, and there is some RF covered in here. So if you're curious on those topics, you can get a free account and you can explore these in our course space. Okay, what else did we have for questions? We were also asked about, We were also asked about Linacs engineering and service processes, including electric circuit flows to different machine systems and their modes of operation. So we have a ton of videos on YouTube. I just wanted to show everybody that if you're curious on learning some things around that, we have tons. All of our webinars are recorded on YouTube. And so you can see all of our webinars here of when we did relative output factors, TMR calculations, and then we even have some more technical ones like beam peaking, beam tuning, beam energy, and unflatness for FFF beams. So we've done a ton of these videos and demos, and they're all on our Linacs Technologies YouTube page. So you can find us on YouTube at Linax Technologies. And then you can subscribe and you can see all of our demos and our videos and get some more lessons as well. Someone asked about access to last week's presentation recordings. And so you can see all of our recordings again on our YouTube page at Linax Technologies. And then just a couple things that were asked about future topics that we might be able to cover are commissioning and acceptance of medical linear accelerators, dosimetry and protocols, conversion of exposure rate constants to air camera rate constant, jaw tracking, and advanced technology radiotherapy. So if that was you that commented that, those are very duly noted, and I'm going to do my best to see what we can do about making some future webinar topics around these topics. Okay, so now we just go through that. That was the questions, and so just this last part before we kind of get into demo, I do want to show you a little bit of the platform as well, just for the sense that the virtual Linacs are half the platform, and then we do have this whole core space which has textbooks, quizzes, labs, and exercises for the simulators to really guide you through learning topics and help you understand the theory behind our linear accelerator beam generation. And then you have the full Linacs then go and demonstrate in practice. So I just wanted to show that really quickly. Like we have a Linac operation theory textbook, and so this is like that primer textbook, but much more content. We've added a lot more images, and then you get a quiz for every chapter to kind of test your knowledge. And then what we see here in our course space, which a lot of people love, are SIMAC labs. And so our SIMAC labs, they kind of take you through a guided experience on our simulator. And really, they just get you to adjust one or two parameters. Like here, we're looking at field size and depth. And you get the immediate output of your dose profiles. And it takes you through a set of questions to really understand the theory we're trying to learn here. And so we kind of start, with those textbooks and the theory, and then you kind of quiz, and then you come to these SIMAC labs, which kind of give you a guided experience off the simulator. And then the last one we have, which is important for people with free accounts as well, is if you come to our student resources, we have some great resources for people to learn different topics. So first, we have a lesson guide here. And so the lesson guide, because we just have all of these chapters and all of these labs and things, it'll tell you how to combine those labs and chapters to learn specific topics. For example, if I wanted to learn about klystrons, it's asking me to read these chapters of klystron overview, description of the klystron model of operation, and magnetic focusing, and then ask me to do lab 2, lab 3, lab 19, and procedure 7 and 9, and that'll give me a good understanding of klystrons. But yeah, so that we do have the lesson guide, and then the last thing we have in the student resources is our procedures. And so these are the next step in our content. So it comes after the SIMAC labs, and then these are guided labs on the real simulator. So I'll show you. This is what our real simulator looks like. It's a full virtual Linac. It allows you to kind of make any beam model, adjust your parameters, rerun the simulation or rerun your beam, and then see how your dose outputs change. And so then there's just the last bit of resources that we have on our platform that's available, and that the lesson guide kind of tells you to do is then our procedure exercises, which then get you on the full simulator, and they really tell you how to go. They really get you to go to each parameter, adjust them, and then look at our outputs and see how they're changing, and again, take you through a set of questions. So we've got really, really good feedback on these, and they're available to everybody. So you can get a free account, and you can get free simulations every day, and then you can use these to really become familiar with the simulator, just because it is complicated. There's a lot of input parameters, and keeping your beam is a little bit difficult as well. So what this just helps you do is it helps you understand which values are within the operation of the simulator, and it really helps you understand where the adjustments for each parameter are within the interface. Okay, so that was a lot. That was just all on our content. I just wanted to make sure that everyone's aware that's kind of the other half of our platform. But now I want to look into our demo of the day, and that's calculating our MUs. So let's go back to our presentation really quickly. And I'm just going to start with a couple slides on the formula, and we're going to break down the formula and look at our what we're going to be doing today, and then we'll jump over to the simulators and we'll do it there. Okay, so let's look at calculating MUs. So why do we need to calculate MUs, or why are we looking at this today? And the answer is really simple. It's because we calibrate our Linacs to know how much dose is being delivered at that location under our reference conditions. And so we measure an output or a dose per MU value for our machine. And that is, like, as we know, our TG51 or our TRS-398 protocol will get us our Linac calibration or our dose per MU in our reference condition. And that's on the left here is representing our reference condition. However, if our treatment is not in the same place as our ion chamber under reference conditions, we need to measure a scaling factor that will accurately describe the number of MUs needed to be delivered to meet your patient's prescribed dose in that location. So we do our Linac calibration under our reference condition to calibrate our Linac to deliver 1 centigrade for every MU at this location. But now in our treatment conditions, where we're treating is not the same location that ion chamber was. And so now we're going to have different factors of our depth, of our field size, of our scatter, contributing to the dose that is not going to be equal to 1 MU for every, or 1 centigrade for every MU. So we need to understand what's changing with our field size, scatter, depth, energy, and apply a scaling factor to that MU to then understand for our specific treatment, how many MUs are we going to need to deliver. And so I want to break down the formula first. So I want to look at the formula and break it down. So this is a very simplified formula. This is a very simplified formula for our MU calculation. And so we have our MU is equal to our prescribed dose times our BW, which is our beam weight, all divided by our machine output times our scatter factor times a PDD or a TMR, depending on our setup, and we'll get to that in a minute, times, I have it represented as OF or other factors, because there's quite a few other factors that can contribute, but these are really the factors that we're going to look at today. And so what we can do is we can break this down, and we can see that our prescribed dose is going to be a unit of centigrade, and our output is going to be a unit of centigrade per MU, which very simply you'll see the centigrades would cancel out and our MU will come to the top. And so then our final unit will be MU, which then means everything else is just a ratio, and it's just a scaling factor that's going to be applied to then say we either need more MUs to deliver to that location or less MUs. And so then generally our output, and we're going to assume that our output is calculated to be 1 MU equals 1 centigrade, which then again makes this formula very, very simple for us to see that it would really just be deliver the number of MUs corresponding to the desired amount of centigrade. However, like we said, that output is only defined in our reference condition. And so as we move from that location, we have to apply our correction factors in order to calculate our MUs correctly. So let's look at our correction factors. So like I said, there's quite a few factors, but we're really going to focus on 3 today. And so our first ones are PDD or TMR. And so these describe how our dose changes with depth in tissue. So as our beam travels into the patient, our dose is going to decrease with depth due to attenuation. So we need a way to relate our dose at depth to our dose at our reference point, which is going to be our Dmax. In an SSD setup, distance changes with depth, so we use our PDD to account for both attenuation and distance effects. In our SAD setup, distance is fixed, so we use TMR to account for depth without distance effects. And then the other factor we're going to look at, and sorry, we can just kind of look, they're calculated very similar. And today, our PDD, we won't use the times 100 because we're just going to use the ratio, not really the percentage. And so they really are calculated very, very similarly with our dose at depth of the treatment divided by our dose at Dmax. And this is our normalized dose, is what we're calculating for, measuring for. So then the other one we're going to look at measuring on SIMAC today is our output scatter factor. And so this is the product. The reason we have our subscript C is for the contribution from the collimator and our subscript P for the contribution from the patient. And so scatter is secondary radiation from our secondary interactions, which create more dose. So our scatter scales with field size and SSD, and the specific patient setup is important to understand our scatter contribution. So the scatter factor is just going to be the ratio of dose at our field size, absolute dose over absolute dose in a 10 by 10 field, both at D max. And then you can see how that would contribute to our scatter, because we want to know the absolute dose in our field and the absolute dose in a 10 by 10 field, and it'll show us how much more at D max we're getting contribution from scatter. Then there are other ones, like I've mentioned, there are other factors, and I just put a couple down here. There's a wedge factor that's common, or an off-axis factor. So if you were doing a treatment with a wedge or you're doing treatment off-axis, you're going to have to do a scaling factor for both of those for as we're going to get non-uniform profiles. So we'd have to add a scaling factor for those as well. Okay, but so now that we understand the formula, let's calculate one for an SSD setup and one for an SAD setup using SIMAC. So our treatment one, they're gonna be very similar. We're both gonna have a 6 MV energy, and we're gonna do a prescribed dose of 200 centigrade. Our SSD setup is going to be 100 centimeters SSD, a depth of 12, and a field size of 40 by 40. Where our SAD is going to have an SAD of 100, a depth of 12, and a field size of 5 by 5. I know these aren't the most realistic field sizes, but they're kind of our min and max. So I just wanted to kind of show, our both ends of the scale with that. So that's why I chose those field sizes. Okay, but this is great. So now we're ready to go to our simulator and go to our virtual Linacs, and then we can measure. What we're going to do today is we're going to measure our PDD or TMR factor, and we're going to measure our scatter factor, and we're going to then calculate our MUs. And what I really want to show you is we're going to look at our PDDs for all of these different beam setups and show that they are really different, and then we can kind of guess or try to interpret the sensitivity that our MU would change with various different changes. So today I am going to do it on our Klystron Varian virtual Linac. We do have a Magnetron or a Electa virtual Linac as well, which has all the same usability. But today I'm going to use our Varian type machine. And why don't we just start by running our reference beam? And so let's get our reference beam of our 6 MV. And so I'll show you kind of how do we set up a beam in SIMAC and how we run one. So you can see here we kind of have our load defaults for energy. And so I'll just kind of toggle between our energies to make sure I load in my 6 MV defaults. And I can kind of confirm my parameters if I'd like to. And then the other thing, just because we're going to do our reference conditions, we need an SSD of 100 and we need a field size of 10 by 10. And so we'll go to our treatment head and we can ensure that our SSD is 100. We can ensure that, well, right now we have a 40 by 40 field. So we just need to adjust this, make sure we have a 10 by 10 field. And there's a couple things that we can do to confirm that once we've run that. But we'll run this, and then we'll be able to see our dose rate will update. I can't remember if I'd run a 6 MV default just before this, or if we're going to get any change in our dose. But we'll see down here, we're running a simulation. Takes about 10 to 15 seconds for our matrix convolution to kind of finish. So there we go, our simulator ran. Yeah, so there's our default 6 MV. And that makes sense, right? Before I did have a 40 by 40. Now we have our 10 by 10. So we have a little bit less dose. And then we can also kind of confirm in our treatment head. Yep, we're only looking at the 10 by 10 field. Okay, great. So now we have our reference beam. So I want to save it so that we can call it back and look at it whenever we want. So I'm going to just say, I'm going to go over to my save state as, and I'm just going to call it 6 MV ref. And I'm going to save that state. And then you'll see, there we go, 6 MV ref is right there. And so then we'll be able to call that beam back whenever we want. And what I'm going to do actually as well is that I'm going to go to our photon beam. And so here's our PDD. And what I can do is I can export our data to CSV, and this will allow us to get our normalized dose distribution data. So we'll call it 6MV ref. We will save that. Oh, already exists. It's almost like I've practiced this before. And so then we'll open up this, our CSV here, and I'll show you what the data looks like that we get out. So on Linac, we can actually look at the graph here, and it'll give us a couple good pieces of information, like our dose at 10 centimeters and where our Dmax is. But then if I really wanted to get into what the dose data is, I can export this to CSV. And so then you see here, I'm getting a centimeter and a dose in percentage. And so we can see, right, at Dmax, we're getting 100% of the dose. Okay, so this is our data for our reference beam. And just for future, because going back to our formulas, for our scatter, we're going to need the absolute dose in our 10 by 10 field. So we can just also grab that right now. But right now we only have the normalized dose. So what we need to do is we just need to grab our dose rate. And then our dose rate times, whatever the dose percentage is, will get us the dose at that depth. So I will just put in dose rate, and we'll put it as 205.67. Perfect. Okay. So now, I'm going to go, and so now what we can do is we can take that beam and we can run them in the water tank to compare them on the same plot. And so we'll do that at the end, but let's go and grab both of our other beams, and we'll get all the beam data, and then we can do all the calculations together. So now with our second beam, so we did our reference beam. So now let's do our SSD setup. So it's very simple. We just need to do the SSD of 100, and we just need to change our field size to 40 by 40. That's the only thing that's changing with our setup here. So let's go back to our simulator. We'll make sure we're at that 6MV. We'll go to our treatment head. We can ensure we're at the SSD of 100, and we'll just go back to that 40 by 40 field that was kind of defaulted when we came to the platform today. And so then what we'll do is we'll quickly save that beam, and we'll quickly grab the beam data from that one as well. And then with this beam data and the beam data from our reference one, we could easily go ahead and calculate our MU right there. So I think we're still running here. There we go. So our dose rate went up, bigger field size, makes a lot of sense. And our dose went up a little bit at our 10 centimeter, but our Dmax is the same, which is exactly what we want to see. And so now let's export our dose data again. And so we'll call this 6MV 40 by 40. Capital MV. Oops. And then again, just because we're going to need the absolute dose, we can also go ahead and record the dose rate after we open this up. That's our reference one. I'll bring in our 40 by 40, and I will say, oh, sorry, I got to admit more people here. Dose rate 223.99. Right, and so now we can get the absolute dose, and we have the percentage depth dose as well. Perfect. Okay, so now for our SAD setup, the only thing that's going to be different is Linac only has an SSD input, so we just have to calculate the SSD off of our from our SAD and depth. So it's very simple. We'll subtract our depth from our SAD, and we'll get 88 SSD, right? And so then we can put that in for our SSD parameter. So our SSD for this one is going to be 88. And then our field size is going to be, we're going down to a 5 by 5. So we're going small. So we'll do that. And then again, we're going to run the beam, and we're going to export the data, grab our absolute dose, and then we're ready to go. Yeah, Karen Ann? What's going on? I can't hear you.
I know, I can't get it off.
What's going on? Oh.
There's been a lot of questions about the recording, so just to tell everybody, so you don't have to message in the chat either, we'll be sending a recording of this for everybody, so don't panic.
Yep, everything. Yes. So tomorrow I'll get that recording, and I'll email every single one personally with recordings. Here's your recording. And then next week I'll post it to YouTube. I'll post it to our social media. We'll spread it around, and then you guys can get access to it, no problem. Yeah, so no worries there. You will get the recording for sure. Okay, did I run my simulation? I can't remember. I did. I did run my simulation because we see my dose rate changed. And so glad I ran it. And so now we can grab our CSV data for our 5x5. So we'll just call this 6MV 5x5. Save that there. Perfect. And then we'll go ahead and open it. And then the last bit, we just need to grab the absolute dose for this one as well. 257.77. Great. Oh, actually, I'm doing this incorrectly. So we can't actually get the absolute dose from, or we can't actually get the scatter factor from this data because we're using an SAD setup. The definition of our scatter is actually the dose at field size over the dose at 10 by 10 field under our reference SSD. Because we want to compare them at the exact same location. Because scatter does get affected with depth and field size, we need to compare them at the same spot. So because we have now chosen an SSD of 88, we need to go and do one more run, and we need to set our SSD to where it would be in D max of our for our SAD setup. So that's going to be it's going to be our 1.6 centimeters off from the 100 SSD. So we'll get our last one. We'll go over to our treatment head. We keep the same field size, but we're just going to do a 98.6 because we have like 1.6 D max. And then we'll run this, and this is where we can then grab our absolute dose to get our scatter factor. So I realize we're coming up on the half an hour, so I'll get to the last little bit here, and then we can kind of compare them all on one plot and see the differences of our PDD and kind of predict what our MUs are going to do. Okay, so we ran our last simulation, got 205, and so then we just need to grab our last beam data here. And so then this is the 6MV 5x5 D max, we'll call it. And so then we can pull this one up, and then this is where we want to grab the absolute or dose rate, so 205.71. Okay, perfect. So now we have all the numbers that we need, and now we can just go and do our calculations. We need to just take a couple ratios, punch them all into our MU calculator, and then we're ready to go. So what we need to grab is, we'll come down to our chart here. So for our SSD, we need to get our dose at 40 by 40, absolute dose, our dose at 10 by 10, and then we need to get our dose at D max for our SSD treatment, dose at 12, and then we need to do the same thing for SAD treatment. So we all know, whoops, I guess I'll have to kind of get out of the presentation. So we all know that our D at D max, that's going to be 100 for us. So that's easy to do. And then what we can do is we can pull up, we need our 40 by 41, wherever that's going to be. Here it is. So we need our 40 by 40. And so what we need to do is we need to get so we did our D at D max, right, is 100. And now we need to get our D at 12. And so we come down, we can go out to our depth here. We can find 12. And so we got 11.897, and then it jumps up to 12.081, and that's 64.8 to 64.2. So let's just say 64.4. And so our D12 is going to be 64.4, which means the ratio of these is simply going to be 0.644. And that's going to be our PDD ratio that we're going to scale our MU, which makes sense, right? Because so if our PDD is on the bottom or our denominator, and we have a 0.644, that means it's going to make the MU number bigger, and we're going to get for more MUs. And that makes sense because we've gotten a larger field and we're deeper than our reference conditions. So we're going to need MUs than what was calibrated at our reference condition, right? And so now what we can do is we can get our scatter factor. And so we just need the absolute dose in our 40 by 40. And so that's pretty simple. All we need to do, this is the wrong one, apologize. We just need to take the absolute, our dose rate, because our dose rate times 100 is going to, like, times the 100% is going to just be what we measured as our dose rate. So we can put our dose at 40 by 40 is 223.99. And then for our 10 by 10, we just need to pull up our reference data wherever it is hiding on me, 6MV ref, and we can use our 205.67 as our absolute dose. And then we would get a scatter factor of, let me just do the calculation quick, 223.99 divided by 205.67. So that's 1.089. And so then our scatter factor, so then that's actually going to decrease our MU. And does that make sense? Because we're at lower, more scatter. And so, yeah, so then we're going to get a bigger scatter contribution. So we need to scale it accordingly. And so now, if we just go back to our formula, it's just going to be our prescribed dose. I didn't really comment much on our beam weight. A beam weight is just if we have multiple fields, but today we're just working with one field. If you had multiple fields, you would just divide your beam evenly by your fields. But today we're just going to use the one field. And so then what we do is we get our prescribed dose divided by our output, which is 1. And then it's just going to be divided by our scatter factor times our PDD factor. So we just want to multiply 0.664. So we're going to divide what our prescribed dose was 200. And we're going to divide by 0.644. And we're going to divide by 1.089. And so 285. So then now our corrected MUs for our SSD setup is now 285 centigrade, which makes a lot of sense, right? Because under our reference condition is a 10 by 10 field and is at that 10 centimeters depth. We've now gone deeper and we had a larger field. So we're going to need more dose to be able to meet that treatment that we'd like. And so we're going to need to deliver more MUs there. And so then we could do the exact same. We are running over time a little bit, so I might be running a bit out of time, but just to show you quickly how we would do it. There's the Dmax one. So here's our 6MV 5x5. And so at Dmax, of course, again, if I can get my things out of the way, of course, at Dmax, again, we're just going to have that simple 100 at dose Dmax SSD 80. It's going to be 100. And then my goodness, too many CSVs going around. And then we would go down to our 12. We would get the value there. And then we would just have to go to our reference data again. So then the dose here is going to be the same. It's going to be 205.67. And then we would get the dose from our 5x5. And then we could calculate our MU the exact same way. So it's more important of understanding that we change the SSD to get these values rather than doing that final calculation. Just because I did promise you guys a half-hour webinar, so I'll kind of wrap it up there. But then the idea I just want to show you to finish is that now we have all these beams. What we could have done is we could have put them all through our water tank, and we could have run them all here, and we can investigate them. So here's our reference beam, and then we want that one. So we have our reference beam, and we have our 40 by 40, and we have our 5x5. And so we can see that the percentage depth doses are very different for each of these setups, and so that's why we have to scale our MUs. And then we can see that our MU, our 40 by 40 SSD, the difference there is more significant. So we would guess that the sensitivity of that change to MU would be larger than the sensitivity in the change from that 5x5 field. And so then we could go to as much as our imagination can run. We could do different energies. We could do flattening filter free. We could do every field size ever imaginable, every SSD ever imaginable. We could set up our reference conditions incorrectly and show how that's going to affect our MU calculation, see where the errors are going to come in. It is fully configurable to then be able to now investigate any beams and compare them to each other and then do these types of calculations like your MU calcs. But yeah, in a nutshell, that was the presentation that I had for you guys today. So I appreciate you guys joining. I do have a couple last slides just to show you that if anybody is curious of getting access to the simulators, we have a couple different options. We have a physics package, which basically gives you access to everything I showed you to be able to manage and deliver your own training. A lot of camp ep programs use our package to support their programs and education. And then we have two service courses. We have a beginner course and an advanced course. So if you're looking to improve your service skills, we have courses to cover that as well. We have a self-directed course and we have an instructor taught course as well. And just as a little overview, these are some of our current physics customers that are using these virtual Linacs in their programs right now to teach things like calculating MUs. So we have tons, ECU, Maryland, Geisinger, Duke's been a great one, Texas, so lots and lots. And I'm happy, we'd be happy to get you in touch with any of these customers if that would be interesting. And then the last bit I want to put up is just if you want to learn more, you want to get in touch with us, this is where you can do it. So if you'd like another physics trial, a physics workshop, a demonstration for your team, please email me, quinn@linacs.ca. More than happy to discuss pricing options, take you through the platform, give you some trial access so you can try it on your own. And then if you're curious, if you're interested in service training, we have an English course coming in on May 5th, and we have a Spanish course coming May 12th, starting May 12th. And you can email Karen Ann at linacs.ca for details on our service courses. Anything to add there, Karen Ann? I just wanted to wave. Yeah,
That's
perfect.
all.
Okay. But again, I mean, thank you guys so much for supporting webinars. I hope that was a useful and enjoyable topic that we covered. And make sure get your free account, try out the simulators on your own. We'll be back next month with a new topic. So please feel free to fire us some messages and let us know what you want to see. And hopefully we see you at the next one. And don't worry, we'll get you your recordings as well. Recordings are coming as soon as possible. Hopefully they'll be out tomorrow. Thank you guys so much. I appreciate you guys joining today. I really enjoy doing these types of presentations, so I appreciate you guys supporting it and letting me do more. Love it. And then we will just end it there for everybody. So unless there's any questions, is there any more questions in the chat, Karen?
Oh.
Just so many, everybody's on auditors and note takers these days. Everybody, is it free? The workshop is free, Christian, and I think you might already be signed up for a workshop, Christian. But our physics package and our service courses they do cost they do cost money, and we do have different pricing depending on where you are in the world and your situation and stuff. So please just reach out and we can definitely help with that. Okay. Yeah, no problem, guys. Thanks for all the support. I appreciate you guys saying thanks in the chat. And I mean, Karen and I will hang out for a minute or two just in case anybody has anything else to say. But if not, that's it. So enjoy the rest of your days, and I'll give you the rest of your day back, give you all your time back. Sorry for going over a couple minutes.
Take care.
Okay. That go okay, Karen Ann? Look okay from your side?
Yeah.
Good. Yeah, it's funny, all the everybody on Otter and
Oh, there's a question for you. Workshop may have any MC workshop?
yeah, I think
Sorry,
yeah. So
Carissa.
yeah, Marissa, yeah, I think we have no, we don't have any on Monte Carlo. We don't do any Monte Carlo yet in our simulations because it just takes too long. It's just too much computation. We can't mess around with our Monte Carlo yet, but we're gonna introduce it eventually for checks, for calculation checks. But right now we don't have any Monte Carlo workshops. Of course.
So we ended here then?
Yeah, I think we'll just end it there, and everybody will get kicked out, and then we'll get you recordings as soon as possible. And like I said, if you just have any questions or just want to learn more, just please reach out to us and we will help. Okay, guys, have a great day. See you later.